Hi viewers, welcome to LMS Solution. Today we are going to see about fuel cell with the battery energy storage system. This is a simulation model we developed for fuel cell with the battery energy storage system for DC microgrid. The system consists of fuel cell stack, and then the fuel cell stack going to be connected to the DC bus or DC load via this boost converter, and this boost converter going to be controlled by means of P&O BPT in order to extract the maximum power from the fuel cell based upon pressure of fuel and air. And then here we have a battery storage system. So the battery storage system going to be connected to the DC bus or DC load via this bidirectional converter. So this bidirectional converter going to be controlled by means of voltage PA controller for maintaining the DC bus voltage at the 48 volt. Here you can see that this is a rating of fuel cell at a nominal operating point that it can generate when you have to operate the fuel cell at 24 volt. It will be generate around 1.26 kilowatts. So it can generate maximum power when we are operating that fuel cell at the 20 volt. Totally it can generate 2000 watts. We can supply maximum of 2000 watts. And then this fuel cell going to be connected to the DC bus. So here we are going to maintaining the DC bus voltage or DC load voltage is 48, and then if here you can see the input voltage we are will be considered as 20 volt, and then the fuel cell rating is 2000 watts. Based upon this detail, the fuel cell power rating, maximum power rating, and terminal voltage of the fuel cell and the DC bus voltage, we need to design that inductor and capacitor values. Next you can see that battery rating. Here we are using a 24 volt battery with the 100 Ah rated capacity. Initial SOC of the battery is here we are considered as 65%, and also we are doing the same kind of design, but here we are going to take the value of boost converter design the LNC, because this battery also going to be used for supplying maximum of 2000 watts. Here also we are going to use the whatever value we designed for this boost converter, that value going to be used for this inductor and the capacitor. And here you can see this boost converter, right? Boost converter going to be controlled by means of P&O BPT. P&O BPT receive two inputs, fuel cell voltage and current. Based upon fuel cell voltage and current, we have to calculate the change in voltage, change in power. Based upon that, you have to decide the duty cycle. So if you want to more information about P&O BPT, kindly visit our YouTube channel. We already posted several videos about P&O. You will get the better idea on that video. Here the P&O BPT will be generate the duty cycle that going to be processed via PWM generator. So PWM generator will be generate the PWM pulse based upon duty cycle, and it going to be control this IGBT in order to extract the maximum power from that fuel cells based upon the pressure of fuel and air. And then here you can see the battery is connected to the DC bus via this bidirectional converter. This bidirectional converter going to be controlled by means of voltage control method. Then here we are measuring the load voltage. That load voltage will be compared with the reference voltage. Here we are going to maintain the DC bus voltage is 48. Here we are compared with the 48 volt, and then it going to process via PA controller. PA controller will be generate the duty cycle. The duty cycle going to be process via PWM generator. This PWM generator will be generate the pulse. That pulse going to be used for control this to IGBT in order to maintain DC bus voltage up to 48 volt. And then here we consider the load is we are taking as 1500 watts. That means V square by P concept. That means here we are calculating R value, P equal to V square by R, and then R which is equal to V square by P. That concept we are calculating the R value. Here load resistance is around 1500 watts you are consider, because if suppose we are going to operate this fuel cell at one pressure, that pressure of fuel cell here will be equal to 1, it can generate maximum power of 2000 watts. Then it can supply the power to the DC load, as well as it can used for excess power going to be used for charge the battery. When the pressure of fuel and air going to be reduced, what happen, the power generation from the fuel cell going to be reduced. So during that time, battery going to be supply the power to the load in order to maintain the power balance in the system. So this system will be always having power balance. That means the source power is always equal to load power. And then here we have a different scope. This scope is for measuring the load voltage, current and power, and this scope is going to use for measuring the fuel cell voltage, fuel cell current and the fuel cell power. And then this scope going to be used for measuring the battery voltage, battery current and battery power. And then here the condition we are created. Here we are using step plus input block. Here we are having step time is 0.5. So initial pressure we are maintaining at 1 bar, and then the final pressure we are maintaining at 0.01 bar. Because of this change in pressure, fuel cell power will be reduced from maximum to some level. So we can see the changes in the fuel cell voltage, current and power, as well as we can see the variation of battery voltage, current and power, and SOC variation, and then we can see the response of load voltage, current, and power. Now I'm going to simulate this model. Before that, I'm going to open that scope of fuel cell, battery, and load. Now I'm going to simulate this model. We will get the better idea in this. Initially, from 0 to 0.5 seconds, the pressure of fuel and air will be maintained at 1 bar, and then after 0.5 second, the pressure of fuel and air going to be changed to 0.01 bar. We can here you can see that initially the fuel cell voltage from 0 to 0.5 second it maintained at 20 volt, and then fuel cell current is maintained at 100, and then here you can see that it generating 2000 watts. Generating 2000 watts, already I told the load power is 1500. Here you can see the load power is maintained at 1500, load voltage maintained at 48 volt, and load current is maintained around 32.5 amps. So now we can see that the generation will be 2000, the load having 1500. Remaining power going to be used for charge of battery. Here you can see that this is a battery voltage, this is a battery current. Battery current here is negative. Battery current negative means battery in charging mode condition, and also you can see the battery power. Battery power also in negative. So from that you can see that battery charging mode. We can see the SOC of the battery. SOC of the battery change is increased from 65%. It start increasing manner. So what's the meaning? Battery in charging mode condition during 0 to 0.5 seconds. When at 0.5 seconds, the pressure of fuel and air going to be changed to 0.01 bar. Because of that, you can see that the fuel cell voltage is reducing to 10, and then current is reducing somewhat, is around 80 amps, and then the fuel cell generating only around 800 or 850 watts. Because of that, what happened? There will be a shortage of power to the load. During the time, what happened? That battery starts supplying power. That's why the battery can change from minus direction to positive direction, and then power of battery also change from minus to positive. And also you can see the SOC of the battery is keep on decreasing. So what's the meaning? Now battery is changed from charging mode to discharging mode because of a change in pressure of fuel and air. And also here you can see that the load side, right? Load side current is maintained at the constant, and the power also maintained at constant. The load always get the power from the system. That means always getting power from fuel cell as well as battery according to the condition of the pressure of the fuel. So this is the working of this model. Thanks for watching our videos. Kindly subscribe our channel and also click bell icon for notification about upcoming videos. Thank you so much. Bye bye.